Okay, so today we're going to talk about today and next class. We're going to talk about your objective is I can solve systems of equations by graphing. So a system of equations. We've actually done things like this before when we were solving for equations with variables on both sides. I think we did one where it was like a gym membership or maybe anyway, I don't remember exactly, but when we've compared two different companies or two different plans and wanted to see when they were the same. Systems of equations are doing just that, but we are going to, I don't know that it gets more complicated. It's just kind of a different way of looking at it, I guess. We're doing it in two dimensions, whereas before it was really just one dimension. So let's say that we had two equations. We have y equals, and there's several different ways to solve these. Sorry, I'm going back. There's several different ways to solve these. The first one that we're going to talk about is by graphing. And it's not necessarily the easiest. It's the easiest to visualize. And if the answer comes out nicely, then it's pretty easy, but sometimes we can only get an approximation this way. So we're going to look at this example problem. We have y equals 3x minus 2 and y equals negative 2x plus 3. And we want to know when are these two equations going to be the same. And the way we do that is we start by graphing them. So I'm going to go ahead and say I'm going to mark this one. This is going to be my red graph, and this one's going to be my green graph. Okay, so for my red graph, for that first one, I'm going to find my y-intercept. My y-intercept is at negative 2. So I'm going to go down to negative 2. I'm just counting each square as a space. So this is negative 2. And my slope is 3. So because my slope is 3, that means my rise is 3 and my run is 1. If it's a whole number, my run is just going to be 1. So my rise is 3. I'm starting at my y-intercept of negative 2, counting up 3 spaces, 1, 2, 3. And then I'm going to go out 1 because my run is 1. And just so that I can draw a fairly straight line, I'm going to do one more. You really only need 2 points, but I'm going to draw one more just to kind of help it stay straight. I went up 3, not 2. 1, 2, 3 over 1. Let me get rid of that rebel dot. Okay, so up 3 over 1. So I have my 3 points now. Again, you really only need 2 points, but just for me, I just wanted a third point just to kind of keep my line straighter. Now let's see if the ruler will let me draw the line where I want to. Get the angle a little bit better. All right, that's close enough. Okay, so I'm going to draw this line. And good there. There's my line for that equation. And that goes on forever. And it actually goes on forever in both directions. I probably should have drawn that down. Yeah, that's not straight. Okay, now I'm going to do my green line. So my green line, my y-intercept is at positive 3. So I'm going to go ahead and go up to 3. 1, 2, 3. I have a positive 3. And my slope is negative, and it's a negative 2. So my slope of negative 2 means I'm going to start at that positive 3. I'm going to go down 2 and over 1. Down 2 and over 1. And you can probably already see where these two graphs are going to intersect, but I'm going to draw my line anyway. And draw my line. This one will actually draw all the way through like I should have done the first one. Okay, and these lines go on forever. And so my point right here, that point right there in the middle where both graphs cross, that is called our solution. What it means is at that point, these two equations are going to come out to be the same thing. Okay, so the last thing we need to do is we need an ordered pair that shows the solution. So we're going to find our x value. that is at x equals 1. So our first number, our x coordinate in our ordered pair is 1. And our y value is also at 1. So 1, 1 is the solution to this equation. Okay, and that's all we're doing when we're solving a system of equations by graphing. We graph each line, draw the graph of each line, and see where they cross. And wherever they cross, that point is the solution to the system.